So thank you very much for your presentation. Good afternoon, everyone. Today I will present my PhD project focused on the formulation of this respirable powder containing cyclosporine A, loaded liposomes, as a immunosuppressive agent suitable for lung transplant rejection and for the containment of severe lung inflammation. So the aim of this work was to develop a respirable powder and this powder contains cyclosporine, which is a well-known immunosuppressant molecule, a small peptide of 11 amino acids that in the tail, this formulation is that we developed containing liposomes loaded with the cyclosporine to prevent the lung rejection after transplantation and in particular to prevent the development of bronchiolitis obliterans after transplantation. And as suggested more recently, this molecule could also mitigate the inflammatory process caused by the viral infection. The cyclosporine, so in that formulation, was formulated as a calcium phosphate in calcium phosphate coated liposomes. In order to try to improve the local availability of the drug, improve potentially the cell uptake, and with this coating, it could be also possible to reach a pH-dependent release because calcium phosphate is soluble only at pH lower than 5. Moreover, with this coating, it will be possible to reduce the.
I'm not sure if we've just lost David there. Are we able to cut to the recorded presentation, please?
And on the formulation of a respirable powder containing cyclosporine A loaded liposomes as a immunosuppressive agent suitable for lung transplant rejection and the containment of severe lung inflammation. The aim of this work was to produce an inhalable formulation of cyclosporine. Cyclosporine is a very well-known immunosuppressant molecule commonly administered with parental or oral route. It's a small peptide of 11 amino acids with a very low solubility in water. In the tail, the formulation we developed was a dry powder containing liposomes loaded with cyclosporine to prevent the lung rejection after transplantations and in particular to prevent the bronchiolitis obliterans syndrome. And as it most recently proposed, cyclosporine could be also able to mitigate the inflammatory process caused by SARS-CoV-2 infection. Cyclosporine was formulated as a calcium phosphate coated liposomes in order to improve the local availability and the cell uptake, and potentially obtaining a pH-dependent release because calcium phosphate is soluble at pH values lower than 5. And moreover, with this formulation, it will be possible to reduce the alveolar macrophages clearance, and the calcium phosphate is also a biocompatible and biodegradable material. Liposomes were prepared by mixing lecithin-soluble acid in ethanol with the hydroalcoholic solution containing also cyclosporine. After the homogenization process, the liposomes were coated with the calcium phosphate, and the best promising liposome formulation were transformed in powder using spray drying process. 3 different formulations were prepared, increasing the concentration of cyclosporine with the aim to maximize the drug loading. So 3 batches A, B, and C, containing respectively 4.8, 7%, or 9% weight by weight of cyclosporine were produced, and regarding the loading, 5.4 or 8.6% were obtained for the batch A and batch B. Regarding the batch C, with the highest concentration of cyclosporine, it was not possible to obtain the liposomes. Starting from the 7% weight by weight of cyclosporine, we produced 2 different batches containing also 30% or 20% of cholesterol to assess the effect of these excipients on the physical properties of the liposomes. The liposomes dispersion were characterized in terms of size, polydispersity index, and zeta potential. And the blue bars represent the values before the coating, and the gray bars represent the values after the coating. Despite the highest drug loading, the batches containing the cholesterol after the coating demonstrate an improved size and a spread polydispersity index. So the batch B was the best in terms of physical characterization. The presence of the calcium phosphate coating was demonstrated in all the batches by the change in the zeta potential values before and after the coating. The presence of the coating was as well confirmed by cryogenic electron microscopy analysis. The pictures illustrate the morphology of the liposomes, and the arrows indicate the regions of the liposomes in which it's possible to observe the calcium phosphate coating. The liposomes were spray-dried using mannitol as a bulking agent, and leucine or sodium stearate were added to improve the flowability of the powders. As previously investigated in another work conducted in this laboratory, the ratio between liposomes and excipients was 1 to 3. And despite all the powders were efficiently emitted from the device, only the powder containing leucine demonstrate a mass median aerodynamic diameter lower than 5 microns and a fine particle fraction of 30%. So in conclusion, cyclosporine was efficiently loaded inside calcium phosphate-coated liposomes, and despite the encouraging formulation data obtained, the big challenge now is to demonstrate the superior advantages of this formulation, and for this reason, in vitro and vivo studies are now ongoing. Thank you for your attention.